And we're back again. Seems like I just finished 9.5. Oh, wait, I just did. All right, you guys maybe, I don't know if you finished 9.5, but 9.6, amplitude and vertical shifting of sine and cosine graphs. So to this point, um, we've seen our usual y equals sine and cosine of x. We've seen y equals a cosine x, where a is our, and sine x, where a is our amplitude. So basically just stretches that curve. And today what we're going to do is we're going to be adding a c onto the back of it. And all this is going to do is give us a vertical shift. All right, so not so hard. That's why we're trying to take baby steps here, a little bit at a time. So we're going to start with our regular sine curve here, because it says y equals sine x plus 3. So this is my regular sine curve, all right, with my midline being right here at y equals 0, right at the x-axis. So now all it's telling me to do is it's telling me to take that midline and shift it up 3. If there was a -3, it would tell me to shift it down 3. But we're going to take this and we're going to shift it up 3. I hate when it does that because now it's going to separate. Yep, it is. Okay, hold on a second. There we go. So it shifted up 3. So it shifted from our x-axis all the way up 3 units. All right, and now that we're just going to take our sine. Now, if we would not on a smart board, I wouldn't be able to do this, but we're going to take our regular sine curve and we're going to shift it so that midline is right in the middle, just like our x-axis is for our regular sine curve. So that red sine curve now is what f of x looks like. F of x equals sine x plus 3. Now, you can do this using your table, just like we had our tables in 9.5, and just add 3 onto your value. So when we got the sine of pi over 2 being 1, we said sine is 1, you add 3. 1, 2, 3, and you end up here. All right? When you had 0, sine of pi is 0, we're going to add 3. 1, 2, 3. You end up here. So you can use tables, or you just can use what we know about sine and cosine curves. That the sine curve starts at 0, it ends at 0, in the middle it's at 0, it increases first, so it goes to +1 and then to -1. All right? So the grid to the right is the basic sine curve on the same grid sketch f of x, which we did. All right, so if you haven't done that yet, pause the video and get that graphed, okay? Again, using your colored pencils is really helpful here. So this is going to be our midline. So right here, this is our midline right here. Now, when we get down to exercise 2, we had one more thing. Now we're going to be changing the amplitude as well. So we have y equals 2 cosine x plus 1. And how I do this is the first thing I start with is my +1. I start with my midline. So basically what it's telling me is my midline is not going to be my x-axis. It's going to be the line y equals 1. But then I'm going to think about that being like my x-axis. All right? So if you remember your cosine curve begins at 1, ends at 1, and in the middle is at -1. So it begins at 1, but in this case, instead of beginning at 1, I'm going to begin at 2 because my amplitude is 2. My midline is the line y equals 1, all right? So if I continue thinking about that, my cosine curve would normally start at 1, but instead of starting at 1, I'm going to start at 2 above my midline. All right, do you see that? And then it's going to end at 2 above my midline. And at the middle, it's going to be 2 below my midline, which is right here. And in between, it's going to be zeros on my midline. So this part of my curve looks like this. And we're just going to reflect that over the y-axis. So this one is going to come here, and then it's going to come here, and then back to my midline again, and then back up to +2. So this part looks like this. And it should be continuous like that. If you're getting something that's not continuous like that, then you made a mistake somewhere. Maybe going to your table might be the way to go next. All right? So we did this, sketch the line on the graph, give the equation of the horizontal line. That was my midline. All right, so we call that the midline. And that midline we just said was y equals 1. And the range of this trig function is just going to be a little bit different. It's going to be from this point on our y-axis to this point inclusive. So what happens is I'm going to have my -1 is going to be my lower bound, and +3 is my upper bound. So pause if you need to. I can show you a little bit how to do this on your calculator using the Zoom trig. You go to Zoom, go to Menu, go to Zoom, and you go to Zoom trig, and it'll give you it'll give you a graph that looks something like this, but not 100%. It'll go between 0 and 2 pi, but it gives it to you in radians that is equivalent to 2 pi. In other words, it'll do 2 times 3.14, which is 6.28, and I'm not a big fan of it, but some people like to use it, and I will show you how to use it in class. Okay, let's move on to exercise 3 when you're ready. For curves that have a general form y equals a sine x plus c, or a cosine x plus c, the value of c is called the midline, or the average value of the trig function. All right, it is the height or horizontal line that the sinusoidal curve rises and falls above and below. The distance of absolute value, or a, is the amplitude. All right, so exercise 3. Sketch and label the function. So we have a couple here. We have y equals 4 sine x minus 2, and we have y equals -2 cosine x plus 3 on the grid below. Try them first without your calculator. Again, you don't have your calculator at home, and if you do, you really should. You should even be able to do this pretty easily without your calculator. So on the first one, we're going to look at y equals 4 sine x minus 2. So on the first one, y equals 4 sine x minus 2. Well, here my a is equal to 4, which is my amplitude, and my midline is going to equal to y equals -2. So what happens with this one is my midline goes, yellow please, I want the midline to come down to here on this one. So what does this one look like? So right now I have this in blue, I'm using blue, so this is the one I'm working on, it's the sine. So I know on my sine curve, I have an amplitude of 4. So again, if you remember your sine curve starts at 0, it ends at 0, and in the middle is at 0. Now normally, in between it would go to 1. So I'm not going to go to 1 this time because my amplitude is 4. So I'm going to go up 1, 2, 3, 4, and down 4, 1, 2, 3, and I have to pull this up a little bit. Down 4, which is down to here, all the way at the bottom. All right, and you're going to just reflect that, right? So no, hit the back. This isn't a reflection. That would be cosine as your reflection, because this one, if you remember, it looks like this. So you can't reflect this one, or it's going to not be right. So this one's not an even function. This one's an odd function when you don't have a vertical shift. So this one is going to come down to here, go back to 0. Remember, it ends at 0, and in between, it's up here again at 4 above it. So this part looks like this. Very easy to do this on a smartboard, by the way. All right, not quite as fluid when you're doing it on a piece of paper. So that's what that one looks like. That's the first one. Sine curve, yep, starts at 0, ends at 0. Okay, so let's take a look at the next one. And that one we're going to do in green. So this is going to be, oh, and this is what's the range of this one. So the range of this is going to be inclusive, right, because they're both closed circles. And it's going to between lower bound, which is negative 1, 2, 3, 4, 5, 6, between negative 6 and positive 2. So between here and here. So now let's do the same thing for our y equals, now I don't, so the second graph is y equals negative 2 cosine x plus 3. So here we have a is equal to negative 2 and the midline is at y equals 3. So this is going to shift up to y equals 3, which is all the way up here. And again, I'm going to pretend that's my x-axis. So I know in a cosine curve begins at 1, ends at 1, and the middle is at negative 1. But in this case, because it's negative, instead of starting up at 1, it's going to go down to 1, and my amplitude is 2. So you're going to start here. We're going to end here. And in the middle, we're going to be 2 above my midline, which is up here. And the zeros in between. So this one looks like this. This one reflects over here, back to 0, down to here. Oop, I made a mistake. So here, I only went to 1. I have to go to negative 1. I'm sorry, negative 2 down here. That makes sense, right? Because I recognized right away that I was not good. All right, so there we go. So that's what that one looks like. And again, it asks us for the range here. So the range here goes between positive 1, 2, 3, 4, 5, and positive 5. So positive 1 to positive 5. I like these. They're kind of fun, a little bit different than what we've been used to doing, all those quadratics and factoring. So I'm hoping you find this a little refreshing, because I certainly do. So exercise 4, so meet me here, pause if you need to, and then come back to exercise 4 with me. So it says determine the range of each of the following trig functions, express your answer in integral notation. So I think the easiest way to do here is like either visualize it, you could even use graph paper if you want to, or you can recognize that with my range, it is going to be, I think the easiest way at this point is, I think you have to do this enough times before it starts getting easy for you. So if you can think about what this looks like, all right? So if this is saying 7x sine x plus 4, so what's happening here is, think about what it looks like. My midline is at 4. My midline is here, right? And then from there, I'm going up 7 and down 7. So I'm going up 7 and I'm going down 7. So when you go down 7 from 4, so you can kind of do it like this. So you're going to start with that 4, because the midline is everything at this point. And you're going to either, and the lower bound is minus 7, and the upper bound is plus 7. So this becomes negative 3 to 11 is my range. And again, if this is ever asked you, you are always given access to graph paper, so just graph it out. All right, but there are times I can see where the numbers start getting bigger, that it starts getting a little bit more complicated. But you can kind of see what's going on here. We're visualizing, and then you come up with a pattern. So the second one says y equals negative 5x plus 2. So again, we're going to start with that midline at 2, and we're going to minus 5. I'm sorry, I don't want to put a parenthesis in there. 2 minus 5 and 2 plus 5. So 2 minus 5 is negative 3. 2 plus 5 is 7. So as you can see here, so to find the range, it's going to be the amplitude plus and minus the frequency, plus or minus the, not the frequency, plus or minus the amplitude. Ah, it's the midline, plus or minus the amplitude. Midline, this is what happens when what I'm trying to think, but I'm looking at my notes instead. Midline plus and minus the amplitude. So here, if we just use that pattern, our midline is going to be 35 minus 25 and 35 plus 25. So it's going to be 10, comma 60. So 5 is kind of a great question because it's really not giving us a lot of information, but it's giving us what we need to know. So it says the graph below shows a sinusoidal curve in the form y equals a sine x plus c. So we know this is sine because if you look at it, it's not reflecting over the y-axis like the cosine curve does. This is an odd function, so it has point symmetry around the point that's in the middle here. So what we're saying here, and you don't even realize it, is that this point right here, or this line right here, is my midline, the one that goes right through the middle. Because we remember that in sine curves, the sine curve starts at 0, it ends at 0, and in the middle is at 0, and the same thing here. So I know this is a positive amplitude. I know it's not negative because it does, from 0, it increases and then it decreases. So I know A is positive. That's a good thing. But now I have to figure out, excuse me, what that midline is. Well, if I know this is a 22, that's a bad 22, 22, and this one down here is at 6, what number is this one? You know it has to be halfway between them, right? So how do you find halfway between it? You could count, but you could also use a little statistics to find the average. 22 plus 6 divided by 2 is 28 divided by 2, which is 14. So I know my midline is the line y equals 14. And I can make sure of that by saying, well, 22 to 14 is going to be how much? 8. And from here down to here, so from 14 down to 6, 14 to 6 is going to be another 8. All right, so, and that gives me a piece of information that I need. That gives me my amplitude. So giving it a check also helps me find out what my amplitude is. So I know my equation is y equals 8 sine x, and then what's my shift? Plus 14. Very cool that we found all that information out just by analyzing this graph a little bit. So just like with lesson 9.5, if you want to do some of the graphs for 9.6 with your colored pencils or your highlighters, it might be helpful to do that and get a head start on it because by the time you come into class, it won't be quite as fresh as it is right now. So I'm not saying do both pages, but maybe try and do 9.6 independent practice number 1 and 2, and just play around a little bit with the midline and what it looks like. All right, so that's it for today. 9.6 over and out. And until next time, always make good choices. Bye.